piecewise functions, and they're going to ask us to, instead of being like a complete piecewise function, they're going to have a variable other than the x somewhere that we have to figure out what that constant is. Okay? So in this particular case, k is some sort of constant, and we have to figure out what that would be that would make this continuous. Okay? We did one a little bit like this whenever we were doing some of the other notes, so you've seen like a little bit of a preview for this. So I've got this function right here is defined everywhere except x equals -2. And then right here, I've got basically just a closed-in dot that's filling it in. All right? So I need to know what this limit is. If I know the limit, then I can use this dot to plug that, hole that's going to be in the graph. Because we can see right here at -2, if I plugged in -2, I'd get 0/0. So we're probably looking at like a hole in the graph situation here. So if I just do the limit as x approaches -2 of x squared minus 4 over x plus 2, that should give me that value I need for my k. So this one is just a factoring problem. And then the x plus 2's will cancel. We will plug in our -2 at this point, so -2 minus 2 will give us -4. So we need to let k equal -4. Okay. Questions? That one's pretty straightforward there for that. And this is typically what you're going to do whenever you see this x does not equal something. Let's look at our next one. So this one is similar, but we've got x is greater than or equal to -20 and x does not equal -4 here. Why did they put that x is greater than or equal to -20 as part of this domain here? What would happen if we plugged in numbers below -20? We're going to get a non-real number because we're going to have a negative under our square root. So this is just sort of part of the setup. We're not going to use any numbers below -20. This is not telling us to make g continuous on all real numbers, just for x is greater than -20, right? So we're really not concerned with this -20 because it's already restricted there. We couldn't ever make it continuous without adding like another piece of a function to it. But what we are going to see is at -4, here we're going to get 0/0. So we've got a hole in the graph probably that could be filled with value at this -4. So that's the value we're really concerned with. So we're going to do limit as x approaches -4 of the square root of x plus 20 minus 4 over x plus 4. And hopefully we hadn't forgotten how to do these yet, but it's been a few days since we've done one. What do we need to do? Multiply by what? Not reciprocal, conjugate. Which might be what you meant, but just not the right word. So, here in the numerator, we're going to multiply together. So we got square root of x plus 20 times square root of x plus 20. That gives us x plus 20. And then our outer terms and our inner terms cancel, so I'm not going to write those down. That's the purpose of multiplying by the conjugate, so that the middle terms will cancel. And then I've got to do negative 4 times positive 4, which will give me negative 16. In the denominator, don't multiply those together. It's something that a lot of you, Connor in particular, was doing a lot. He was multiplying his denominator back together, and then he'd have to factor it back out to get something to cancel. So just keep it factored. So x plus 4, x plus 20, squared x plus 20 plus 4. Oh, and I'm being lazy. I need that limit notation. Okay, now we can just combine the numerator, and we get x plus 4 over x plus 4 square root of x plus 20 plus 4. And now the x plus 4s can cancel. Make sure that you recognize here that square root of x plus 20 plus 4, it's in the denominator. So when you plug in here, what has to go in the top? You'll have that 1. Okay? So we'll have square root of negative 4 plus 20 plus 4, which will be 1 over square root of 16 plus 4. Square root of 16 is 4, so 1 over 4 plus 4 will give us 8. So 1/8. So K has to equal 1/8. The first two that we've looked at here basically boil down to like just a different way of asking you a limit problem, more or less, right? All you're doing is that limit for those. This next one, however, is going to be a little different. All right, so it says for what value of C is the function defined by this equation continuous at x equals negative 1? So this is only asking us to make this function continuous at the point x equals negative 1. So we only care about the two functions that come together at negative 1. It does not tell us it's got to be continuous at 2. So we're only concerned with the two functions that come together at negative 1. That 2x minus 3, it doesn't even have to be there, right? We're not going to use it. Now, if they had asked continuous everywhere, we'd have to consider both. But they did not do that on this problem. So, if our function is continuous at negative 1, that means the limit from the left and the limit from the right have to equal each other, right, so that we have a limit. You also have to have f of negative 1 has to exist and it has to equal. What we have here is like an open circle, closed circle situation. So if the limits equal each other from both sides, we've got an open circle on one and a closed circle on the other, so it's going to be continuous. On these types of problems, it's not asking you to prove it continuous, so you don't necessarily have to go through those 3 steps like we have been doing, but you do need to consider, like, those were both open circles. There would be no way for this to be continuous. I don't usually give that to you. So our big concern, limit from the left and limit from the right have to equal each other. So our limit as x approaches negative 1 from the left of f of x has to equal the limit as x approaches negative 1 from the right of f of x for this to be continuous. Now, whether or not you choose to write that step, you could skip it if you want. From the left, I would be using the negative x equation, right? And from the right, I would be using negative x squared plus x plus c. So for these, we are only just plugging in the -1 for the x, okay? So I would plug in -1 here, and I'd get -1 on that left side. Over here, on the right-hand side, I would do -1 squared plus -1 plus c. I don't replace the c because it's not c approaches -1, it's x approaches -1. So that constant has to stay there. And so that gives us a +1 equals, I've got -1 squared. -1 squared is +1, but you still got to keep that negative that was out here. So you get -1 here, -1 plus c. 1 equals -2 plus c. If you add that to both sides, you get a c that is equal to 3. So that would be your answer. Okay, questions here? Okay, this one is calculator active. So grab your calculators, because I think I need to teach you a new trick on these things. All right, so I want to make this particular equation continuous for all real numbers x. And I have to find the values of a where this will work. I'm not sure if that should say value or values. Usually what they'll do is if there's a possibility for more than one value, they'll put that s in parentheses so that, that it includes those. So this is similar to the last problem. This is an exponential. Exponentials are continuous everywhere. This is just a line. Lines are continuous everywhere. So the only problem we're going to have is going to happen at 3. Okay? So we will have, we need to say that the limit as x approaches 3 from the left of f of x needs to equal the limit as x approaches 3 from the right of f of x. So from the left, e times e to the ax is what we're using. So we're doing the limit as x approaches 3 from the left of e to the ax. And on the right, x approaches 3 from the right of 2x plus a. So, to do these limits, we're plugging in 3 for the x. So plugging in 3 for the x here is going to look like this, e to the 3a on the left-hand side. And then over here, we'll have 2 times 3 plus a. So we end up with e to the 3a equals 6 plus a. Okay, very similar to what we did on the last problem. But on the last problem, we knew how to solve it very easily whenever we got to the end, right? It was just a basic linear equation. I could have given, this to my Math 1 kids and they could have solved it right here. like even really like right now, most of them could solve 1 equals negative 1 minus 1 plus c, right? So it was a very simple equation. This, not so simple. You might like try to solve it by taking natural log of both sides, but here's the problem. If you do that, like I'm gonna do this, but you don't need to write it down because this is gonna dead end. So like if I tried to natural log both sides here, I'd get 3a equals natural log of 6 plus a. The problem is here, it got rid of the e over here, but now I have a natural log that has an a inside. So the only way I could get rid of that natural log is to do e to the a, and you just bounce back and forth. You wouldn't really get anywhere with that. So unless there are mathematical methods that I'm unsure of, I do not know how to solve this by hand, I don't think. Pretty sure not, anyway. So, we could do, I don't think it. Anyway, we definitely don't know how to solve it by hand easily, and I had this beautiful little calculator up here in the corner, so let me show you something super cool about the TI-89. So just open your calculator up, just go to the home screen. Alright, right here, you're going to go to F2, where it says algebra. Alright, so we're going to hit our F2, up there where our little tab says algebra. What's the first thing you see? Solve. You are going to tell it solve. Alright, and whenever you're using the solve feature, it's going to say solve, and you're going to type in your equation, and then for solve to work, you have to put comma, x, or whatever variable you are using. This will do it if you use a's. So like you could hit alpha a and you could use a's for the whole thing, because as long as you tell it what variable, it will do it with an a. It's easier to type an x because you have a button for x, so I usually just change my variable to be an x when I type it in, but you can do it either way. So all you've got to do is you do e, where is e on this one? Right there. E to the 3x, equal sign is right here, below your x, 6 plus x, okay? So I've typed in my equation, but I have to tell it what variable to solve for. It can even do this if you've got more than one variable and solve it, I think. So you hit comma, x, and then you must close your parentheses, because in this calculator, on the 84, if you don't do your closing parentheses, it doesn't care. On these, it cares. If you don't have that closing parentheses, it's going to count it wrong. You're going to hit enter. It may take it a while. You may get a warning. More solutions may exist. Hopefully this doesn't break it. I will say sometimes we try to solve equations and it breaks it. And we get x equals 0.630563. We get x equals negative 6. Don't hit enter again or anything. If you hit the over button, if you go up here, hit the over button, it'll give you another negative 6. I'm not sure why it did that. It is possible that it's actually like a negative 6.000000001 or something like that, because it does have that decimal there. But if it's correct to 3 decimal places on the AP exam, it's fine. So these calculators, the reason that we don't let you use them before now is because they solve all equations. So, you know, my Math 1 kids, they could just do, they could go down here if they were trying to solve x plus 2 equals 7, and they could do comma x, and it would solve it for them and show them that the answer is 5. Now, hopefully they wouldn't need to cheat on this one. Uh-oh. Does it have an error?
No, I think that's right.
Sometimes these just take really long. You guys did not hit the green button before you hit enter, did you?
No.
I typed it in again, but I didn't hit enter. When I hit enter, it's okay, the same thing you got. But then when I hit the green button, in there again, I don't know why yours is different than everyone else. If it ever does that, try green button and see. Because it did work once I did that. I'm not sure why. Yeah. All right. Is everybody getting theirs to solve? All right. So this is a feature that is helpful. A lot of kids use the TI-84 instead of the 89 when they take this exam. I think there is an advantage to the 89 because it will do stuff like this. But the other option, if you can't get it to work for some reason, if solve is not working, every once in a while you may type in the solve equation and it might break your calculator. It might freeze it up and it won't work for like 30 minutes. Because it's too hard for the calculator to do. I need to remember how to do the hard reset on these and tell you guys. I think hard reset is second, left and right button, and the enter button, like all at one time. So if like your calculator ever is, let's see if that's right.
Second, 6, F1,
It won't let you do the second, 6 stuff if your calculator's frozen. So if it gets frozen, I think it's second, left and right arrow, and then the on button. And that'll do like a hard reset where even if it's frozen, it'll go back. So second, left and right, and on button, you got to hit them all at one time. If you ever break your calculator by doing that, if you hit all those buttons, it'll unfreeze it. Because there are a few times that it freezes. Also, for the AP exam, I will send a few extra calculators. So if you break your calculator trying to solve something and it is frozen, you can always ask the administrator to trade calculators out with you and let you use one of the other ones I have. Also, cool thing about the AP exam, you do not have to reset your calculator for the AP exam. You can, but AP knows this, and it's not going to help you because you can only use the calculator. There are 45 multiple choice questions. You can only use the calculator on 15 of those. And honestly, out of those 15, only about 7 or 8 require the use of the calculator. The other ones are going to, in that section, are going to be like theoretical graph sort of problems or limit problems with where the calculator won't help you. So you got like 7 or 8 multiple choice questions that require the calculator. You're going to have 2 free response questions that you can use your calculator on. And they take great pains to make sure that in those sections, if you have like saved a bunch of formulas and stuff, those formulas are not going to help you on those sections anyway. So I do not, I mean, you can technically you can store whole files on here that would have every formula we ever need on it. And it would be helpful if you could use the calculator on the non-calculator section, but you cannot. So it's not going to be useful to you to do that. But it is kind of nice because you don't have to worry about ever resetting them for anything, or worry that maybe you didn't do something right on them. So they don't have to be reset. But that's not nearly as big of an advantage as it sounds like it is. Because basically, if it's calculator active, I haven't shown you guys this yet, but F3, number 3 is limit. If I want to do the limit of x plus 2 over x plus 2 times x minus 4, and I tell it as x approaches -2, because that's where you are going to care about this. Oh, I forgot a parentheses. What have I done? Oh, I think I do comma x, comma -2. It'll do the limits for you. So, on the calculator active part, the calculator will do everything for you anyway, so having the formulas in there doesn't really help you at all. So, you will not be allowed to use calculators on problems like that, so it will not help you, but limit stuff usually is not calculator active on this. So, let's continue on. Alright, this one, we want to know what value of b, if any, will make f of x continuous at x equals 1. Alright, so, what value do I need the limit from the left and the limit from the right to equal? It needs to equal -1, right? Because f of -1, I'm sorry, I got that backwards. Not f of -1. F of 1 equals -1, right? So that tells me for this to be continuous, the limit from both sides have to also equal -1. So you got a couple options on this. You can do limit from the left equals limit from the right, or you could just take the limit as x approaches 1, because 1 is our, we're looking over here. 1 is the place we're going to have trouble. And it's only worried about continuous at x equals 1, because technically this is not going to be continuous here at 4/7 either. But we're only worried about 1. So, even though it's not defined there. So, the limit as x approaches 1 from the left of f of x, I could set it equal to the limit from the right, or I could just set it equal to -1. And so I would get, that would be doing limit as x approaches 1 from the left of b minus bx minus x squared. Which letter am I replacing? X. So it's b minus b times 1 minus 1 squared. So this would be b minus b minus 1 equals -1. So that would be, that would be -1 equals -1, which is always true, right? So this part is telling me that basically it could be all real numbers. which might be true, but we need to check the other piece of the graph, because while b could be any number here, it might not be able to be any number on the other side. Okay, so if we do the limit as x approaches 1 from the right of f of x equals -1, that would be the limit as x approaches 1 from the right of 3 over x minus 4/7 minus b. We are plugging in, this should equal -1. We're plugging in 1 for the x, not the b. So it's 3 over 1 minus 4/7 minus b equals -1. What is 1 minus 4/7? 3/7. So 3 divided by 3/7, dividing fractions is easy as pie. Flip the second and multiply. 3's will cancel. We're just going to get 7 right there. Minus b equals -1. And so we can solve this, right? So if I subtract 7, negative b equals -8. And so b would equal 8. So even though it didn't matter for the first equation what we had, it only works to have 8 for the second equation, so 8 needs to be your answer. I also could have done this just by setting the limit from left and right equal to each other, although I would need to make sure that that limit equals -1, because if it doesn't, then you're not continuous at that point anyway. Yes? Because up here when I did this from the left, I got that my b's canceled out, and I just got like -1 equals -1. So that means all real numbers. When you get a true statement like this, this is all real numbers. And it is true that if we were only looking at the numbers that would make this -1, anything would work. So it could be 2, it could be 7, it could be 55, it could be -42, it could be anything. That would work for b minus bx minus x squared and the -1. However, it would not work for the b down here, and the b's have to be the same in both places. So since the only answer that works for that second one that we did is 8, then 8 needs to be your answer. Now, if you got different answers for your b's, if you got like a 5 for the first equation and an 8 for the second one, that would be an issue, because that would mean it could not be continuous. That shouldn't happen on a question that's worded like this, because it's saying that there is a value that will make this continuous. Actually, no, maybe not. It says what value of b, if any. So if you got like a 5 for the first one and an 8 for the second one, you would say there's no value for that. I guess it's worded where it does leave it open for the possibility that this just cannot be continuous. All right. Okay. All right. This one's kind of a review problem, but we haven't done one like this that had these graphs, and we had to show that it was continuous. So it tells us to determine if g of f of x is continuous at x equals 1. We cannot just look at the graph and tell here, because we don't have the graph of g of f of x, right? So we're going to have to sort of go through our process for this. So we need to first think about that limit, right? We got those 3 things. This asks us to justify our answer. So the first thing that we want to show is that the limit as x approaches 1 of g of f of x exists. I'm going to put a question mark right there because we don't know yet. We haven't proven it, right? But that's what we want to show. And so if we're doing the limit as x approaches 1 of g of f of x, let's see, we're going to have to approach it from the left and from the right here, because whenever we do this limit, we're going to do f of x first. And do we get the same value from the left and from the right here? We do not. So we've got to do this limit from the left and right. So limit as x approaches 1 from the left of g of f of x. It's been a little while since we did these. So I do the limit of f first. So from the left-hand side, what value does f approach? 2. So that means now we'll be doing the limit as x approaches 2 of g of x. Now, let's remember we also have to pay attention here. As we approach from the left, are our values coming from above or below or both sides? Above, right? So we're thinking about from the right here. And so it really doesn't matter for this particular problem, because at 2, what does g of x approach? -2 from both sides, so it's also from the right. So we get -2. So our limit from the left of g of f of x is -2. Now I know from the right the limit is different. The question is it going to be different for g of f of x, not just f of x? So I've got to try this from x approaches 1 from the right of g of f of x. So from the right-hand side, what is our limit as x approaches 1 of f? 0. So we're doing limit as x approaches 0. Is it going to be from the right or the left or both sides there? It's going to be from the right because we're coming from above here of g of x. Although it actually ends up not really mattering much here either, because this is from both sides. On g of x, what do we approach as we approach 0? Our -2. So the limit as x approaches 1 from both sides of g of f of x, since the left and right were the same, it does equal -2. So we have shown that yes, that limit exists. What else have we got to show for continuity? There's 3 things. We got to show the limit exists, we got to show something else exists. What is it? At that point. So we got to show that g of f of 1 exists. Okay? Does it? G of f of 1, does f of 1 exist? It does not. F of 1 is undefined. So, g of f of 1 is undefined. Alright. So, the last thing I would want to show is that they're equal to each other, but if I get an x on any of these, if it's not true, then it means that we're not continuous, right? So we would conclude that g of f of x is not continuous at x equals 1 because g of f of 1 is undefined. So what we've got there, we've got a hole in the graph, right? Now, if I had checked g of f of 1 first, I would not have even had to do the limit. I kind of purposely did the limit because I wanted you to think about what would happen with those limits if you were doing this problem. But if any of it's not true, then it cannot be continuous. This, of course, shows that we are not continuous here. All right. So, assignment for today. Well, let me go ahead and give you, I'm gonna explain a few things because tomorrow I have a doctor's appointment at 9:30. I am going to be here for smart breakfast because my pre-cal has a test, and I got to drop the kids off at the elementary school anyway. So I will be here for smart breakfast, but I'm going to leave you guys whenever class starts or shortly thereafter. Miss Hendricks is going to be here with you. So tomorrow I'm going to go. So you will have a AP classroom assignment is your assignment today, and then tomorrow, you've got 2 other things that you are going to do. So today, you might get done with the AP Classroom before the class is over. So here are my requests for you. I'm going to give you 2 things that you have to do after that. So we will start our free response quizzes next week. So I'm going to go ahead and give this to you so you've got it, and Ms. Hendricks doesn't have to pass it out there. So, free response quizzes, how they work. Now, this will probably be the shortest free response assignment you have the whole time because we don't know how to do much yet. So, it's hard for me to give you free response stuff. So, on this page, you have the first one is a complete free response question. It is from 1978. So, back in the very old problems, a lot of times like question 1 would be all about, maybe one of the first units. And question 2 might be all about like maybe the second unit. They don't do that much anymore on the newer questions. Usually what they'll have is they'll have like a heading, they'll have the stem for the problem. And then part A might be from unit 1, but part B might be from unit 3. And part C might be from unit 5. So there's not a lot of new questions that we can do completely yet because of that, because we're only in Unit 1, so there's not a lot that we can do. So if you get complete free response questions right now, they're probably going to be old ones, which are still helpful. They're a little different than the way they ask them today, but they still, usually there's still pieces of it that you'll see in the newer questions. So they're still helpful. And then some of the other times, I may not give you a whole free response question. So like 2, 3, and 4, all I've given you is like a piece of a free response question. But free response questions will normally look like number 1, where you have a stem for the problem, and then you have like parts A, B, C, maybe D, depending on the problem. There. So you've got 1 full free response question, and then you got 3 partial free response questions that you have this week. So you are going to work on these all week. They are going to be due on Friday next week. Okay. I will tell you that we do not know how to find horizontal asymptotes yet for part C on number 1, but those are the things that we're doing Monday and Tuesday next week. So by Friday, you will definitely know how to do them. You just might want to hold off on that piece right now. We don't know how to do number 2 yet because we have not done limits as x approaches infinity, unless maybe you remember how to do them from pre-cal, because we did a little bit of it then. 3 is like what we did today, so you should be able to do that, although it's a little bit of a difficult problem. And you should be able to do 4 as well. So really, you can't do 2 yet, and you can't do part 1C yet because I haven't shown you, but by Tuesday, you'll have the information to know how to do that. So this will be due on Friday. You are welcome to work together, look on the internet for answers. I guarantee you, especially for that first one, because it's an actual free response release question, you can probably find 10 different people that worked it out. You might even be able to find a video of somebody working it out. I do not want you to do that first. I want you to try to do it yourself first. But if you can't figure it out, you can come ask me, you can ask a friend, or you can look it up. That's fine. I want you to teach yourself how to do these, or, come get help from me there. So what's going to happen on the free response quiz on Friday is, and this is the way it'll work every week, because from here on out we will have them every Friday, unless it overlaps with a test or something. I might need to move it a day or two one way or the other, but generally every Friday. So you'll have one of these assignments every week, and then every Friday you will have a free response quiz. On the free response quiz, I will pick a free response question. Now, when we get to be able to do all complete questions, it will be number one, the whole thing. All right. Right now, we can't really do a lot of full questions. So what I'll probably do is I will probably pick maybe 3 parts. So it might be I pick 1B, number 2, and number 4 for this. So I will pick it could be anything. So if it's 1, I probably won't pick all 4 parts of 1. I might pick a couple parts of 1. I randomly select these, so what I do, I usually just type it into Google a spinner or something, and I randomly choose. So I do that to kind of keep you and I honest on that, so that, but this is the same assignment they had last year, but the ones that get picked for the quiz might be different. I might have picked 2, 3, and 4 for them. I might pick 1A, 2, and 3 for you or something. So it's the same assignment they had last year, and will be unless we get way off of the schedule from where they were. I might have to adjust it some. But the ones that get picked for the quiz may be different. Also on the quiz, you will have one question, or in this case, it might be a few parts of questions that you have not seen before. So, so they will be on things we've gone over, in here. But you will have one that you have not seen before. This is going to count as 15 points. It goes in the free response quiz section. We don't have anything in that section yet. It's worth 20% of your grade. So it's a pretty good chunk, because I want these to be important for us. Then the quiz itself is going to be worth 18 points. So this should be a 100, because you can ask me, ask your friends, look up the answers on the internet. In fact, I think I have the solutions posted. I usually will post, I may not post them right away for this one, since it's the exact same as we did last year. I've already got the solutions posted for this. I post my solutions. You could just go down there and copy them down and not understand a thing if you want, and it's going to get you 15 points here. It will not be good for you on the actual quiz if you don't understand it. But the actual quiz will be 9 points of that will be made up of the questions that you have seen before. So if you know this stuff well, you've already seen it, you understand it, you should be able to reproduce that on that part of the quiz. So those 9 points, hopefully you'll do pretty well with. The other 9 points is going to depend on how you do on that problem that you haven't seen before. So I put those together because free response questions, if you get 6 out of 9 points, that's pretty good. On the AP exam, I would consider that to be a good thing. But obviously 6 out of 9 is not a very good grade for me to put into the computer, right? So that's why I give you points for this. That's basically effort only, and you also have some of those you've seen before. So it's really just that new question, hopefully, that you're going to miss much on. Although, as the semester goes on, I often find that students don't work very hard on this and don't really understand the questions, and then they start missing the stuff they've seen before and the new question, in which case we have some bad grades sometimes. So, make sure you're taking advantage of all those easier points, because the other points are not going to necessarily be easy to get. Not impossible, but not super easy. Okay. So, any questions on free response quiz? The quiz will be next Friday. This will be due next Friday. Okay. So I want to give you that. Then we also have on AP Classroom. AP Classroom has progress checks for each unit. The idea of progress progress checks whenever they started was for us to give you these as like a little quiz, and it lets teachers know how we're doing. However, AP has told us that we are not allowed to give real grades on this. We can give completion grades, like you completed it, but we cannot give we cannot use this like a test. The reason that is because they want these questions to be like, for students to see like how they're doing on stuff and what they're missing, not like high pressure. Plus you'll be able to find answers to these on the internet also, so they're not very good test questions, you know. So tomorrow your assignment will be to do the Unit 1 progress check, both the multiple choice and the free response. Okay. On the multiple choice, you're just going to do those in AP Classroom. You'll put your answers in. On the free response, it has one free response question. Let me make sure we can do all the parts of it. And make sure I don't need to tell you to hold off on one of the parts. We can do that. All right. D's gonna be a little tough. Difference quotient. What is a quotient? Just like a fraction, right? Things that are divided. So think about a fraction there that you could write to approximate. Actually, don't do D. A through C on those. Because that instantaneous rate of... Oh, no, okay. No, never mind. Let me just give you a quick hint on this right here. Instantaneous rate of change, that's what we were talking about at the very, very, very beginning. Right? So, instantaneous rate of change would be like when we were talking about like that car's speed at that exact point. Right? And when we had a graph, how did we find instantaneous rate of change? Like, let's say if we were like right here. We took 2 points close to it and we found the slope, right? Or, you know, maybe if they ask you like 1.5, it would just actually be the slope of that little segment since it's a straight line. But when you see, so we can do this. I was just not reading it correctly. Difference quotient, think slope. Okay, that's what it's asking you for there. Because I know that wording is a little tough. So think about slope that would approximate the instantaneous rate of change. Instantaneous rate of change is like your speed at that instant, your slope at that instant. So we should be able to do everything for this one. Let me make sure. For the second one, yeah, you should be okay there as well. Now, they're not easy problems. I'm not saying it's going to be easy, but we've covered what you need to know for that. Just making sure it didn't have any infinities in it there. So, tomorrow, that's the main thing you're going to work on in classes, the progress check. I am going to leave unit circle quiz and trig identity quizzes. Okay? So, trig identity quizzes, I put it on Canvas there. I'll show you what the blank one will look like.